Good morning and welcome to section 5.1 rates and ratios and rates. This is the beginning of a new unit and we're going to say goodbye to algebra for a little while. We'll be taking brief trips back to some algebraic concepts, but for the most part we're kind of done with that. And some of you are going, yay, and others are going, oh, I liked algebra. But this is kind of an interesting unit also. So we're going to start with talking about three different terms. Ratio is a comparison of two quantities using division. So when we compare similar things like three girls to four boys in a group, we would use a ratio. A rate is a ratio, so it's against the division problem, of two quantities with different units. So 60 miles per 2 hours. The third kind is something that you probably are a little more familiar with but didn't realize it had a special name. And a rate with a denominator of 1 is called a unit rate. So if you go 30 miles per hour, you go 30 miles per 1 hour. You won't say it that way, but that's really a unit rate. So you've been using it all this time, not realizing it was a really kind of special kind of rate. So we're going to start with examples. Example 1, finding ratios and rates. There are 45 males and 60 females in a subway car, and that subway car is traveling 2.4 miles in 5 minutes. So we're going to find the ratio of males to females. So we want to know what in a ratio, it's a division problem, and we start with, say, males to females. So it's males divided by females. And no, we don't ever really want to turn this into a decimal. We want to keep it as a division problem because it defines a ratio. So there are 45 males and 60 females. And ratios you always simplify. And we divide this and we get down to 3/4. So we divided both sides by 15 to get 3/4, or 3 males for every 4 females on the subway car. So you would write it as the ratio of males to females is 3/4, or 3/4. So now we also want to find the speed of the subway car. And we know that it's traveling 2.5 miles in 5 minutes. And we are looking for miles per minute, which is kind of a weird unit. We don't really think of it that way, but we're going to, for this case, we are. So we know that it goes 2.5 miles in 5 minutes. That's stated in the problem. And we want to say, since it's miles per minute, 2.5 miles per, and when you have different units, you always put them into the ratio, or the rate, per 5 minutes. And since this is a unit rate, we want this to be 1. So figuring out how to simplify it is easy because you divide by the same number. So 2.5 miles gives us 0.5 miles per 1 minute. So you would say the speed of the subway car is 0.5 miles per minute. So for every minute, it's going half a mile. All right, our second example is finding a rate from a ratio table. I kind of move you over so that hopefully my face isn't in the way of what you can see. So a ratio table shows the cost for different amounts of artificial turf. Find the unit rate in dollars per square feet. And for every 25 square foot of artificial turf, it costs $100. And then this grows in this table. To actually get from here to here, you are multiplying by 4. And to get from here to here, you are also multiplying by 4. To go from here to our next one, which is 400 square feet and costs $1,600, you are also multiplying by 4. And then our final one is 1,600 square feet and $6,400. This is being multiplied by 4. To go from here to here and from here to here, these three numbers don't have to be the same, but the number here and here do have to be the same, and that defines a constant change. So in all of these problems, the numbers that when you multiply to go from one to the next in these ratio tables, these numbers will be the same, but they do not have to be the same across the top and across the bottom. So we're going to use a ratio from the table because we want to figure out what the unit rate is in dollars per square feet. So we're going to say the cost divided by the amount. And just because the ratio table is the amount and then the cost does not mean that it always has to be represented that way in a ratio. So the cost is $100. We're going to, now that we're making a rate, we are going to include the units so it's $100 per 25 square feet. And we want to simplify that down to be a unit rate. So we're going to divide the top and the bottom by 25. Since it's 25 square feet, we're going to divide it by 25. So 25 divided by 25 is 1, so 1 square foot. 100 divided by 25 gives us $4. So for every square foot, it costs $4. Okay, so let's go on to our next example. Actually, on your own, you're going to use the information from the previous example to find the ratio of females to males. You're also going to find a ratio of females to the total passengers, and the ratio table below, you want to find the speed in miles per second. So pause me and then come back. Hi, welcome back. So in this case, when we were finding the ratios from females to males, you just invert it. We have 60 females and 45 males, which still gives us, we divide both sides by 15, we get 4 females for every male. And finding the ratio of females to total passengers, there are 60 females. And to figure out how many total passengers, you just add the number of males and females, and we end up with 105. And we can simplify that down to 4/7, because both are divisible by 15. So in the ratio table below, we are going to figure out the miles per second. So we take 14.4 miles and divide that by 3 seconds. And we are going to divide the top and the bottom by 3 using a calculator. I get 4.8 miles per 1 second. So that is moving very quickly. And we usually write it like this: 4.8 miles per second. So that's moving really fast. One last thing before we go on to finding rates from graphs and things. A complex fraction. So this would be a complex fraction has at least one fraction, the numerator, denominator, or both. 14.4 is a fraction because we can write that as 14 4/10. You may need to simplify the complex fraction when you're using ratios and rates. So if we had to simplify that in order to figure this out, in this case we didn't, because we just divided the top and the bottom by 3. You would multiply the top by 10, so you would have 144, and you would multiply the bottom also by 10, because if you multiply the top by something, you have to multiply the bottom by something. So you'd end up with 144 over 30. And it's going to come up in your homework.